Hello there, and a very calm, soft, and soothing voice, slow-paced, with gentle welcome to the Cosmic Lullaby channel. Tonight we are not looking up at the stars, but down, deep into the ancient and extraordinary world of geology. We are listening to the deep memory of our planet, a story that is written in stone. Long before any stars were given names, or the oceans had known boundaries, the Earth was already alive, already breathing, quietly reshaping itself in the deep cosmic silence. Mountains rose from flat plains only to crumble back into dust. Entire seas vanished and then, after epochs, returned. The continents themselves wandered across glowing oceans of molten rock, silent, patient rafts on a journey with no destination. The very ground beneath you, beneath your home, is ancient beyond all imagination. And yet, it is not still. It is still moving, still breathing, and still, ever so slowly, changing. This is the story of geology, a tale of fire and water, of creation and of collapse, a story of a beauty that takes millions upon millions of years to unfold. Beneath every single step you take, within the heart of every pebble you might hold in your hand, there are whispers. Whispers of volcanoes and glaciers and stars that have long since gone. These stories are not loud. They do not demand our attention. Instead, they wait. They wait for us to grow quiet, to grow still, and to listen to the slow, deep rhythm of the world. It is a rhythm that can quiet our own racing thoughts and cradle us in a sense of time that is vast and unending. So, for now, just breathe. Let your eyes grow heavy. Let your mind soften, and allow the ancient earth to hold your thoughts. Let's begin. The Earth's crust is thinner than you might imagine. It is a thought that feels almost impossible, yet it is profoundly true. If you could shrink our entire planet down to the size of an apple held in your palm, the crust, this solid outer shell we live on, would be no thicker than the skin of that fruit. All of our continents and all of our ocean floors, together they form this impossibly delicate layer, extending on average only about 30 kilometers deep beneath the land, and less than 10 beneath the deep sea. Think of that. All of human history, every city we have ever built, every forest that has ever grown, every war that has ever been fought, has happened on a surface so fragile it could almost disappear in scale. Beneath that thin, delicate skin lies the mantle, a vast hidden region of slowly flowing rock that makes up most of the Earth's entire volume and mass. Our crust, our world, simply floats on this mantle, like a collection of fragile rafts on a hidden sea. We are all adrift on these molten currents, carried and reshaped by the patient, silent power of plate tectonics. Our grandest mountains, our deepest valleys, and our vast ocean trenches, they are all just tiny, insignificant ripples on the surface of an enormous sphere of stone. We build our lives around these features. We name them, we map them, we believe they are permanent. But they are fleeting expressions of a much deeper, slower process. A process that was at work long before us and will continue long after we are gone. This thinness, this fragility, isn't a reason for fear. It is a reason for wonder. A very calm, soft, and soothing, slow-paced, with gentle intonation, designed for relaxation and meditation. It shows how life has found a way to thrive in the most precarious of balances, on a thin, cool surface just above an ocean of fire. Consider the granite that forms the hearts of our mountains. Long before it hardened into the rugged, speckled stone we see today, that granite was alive with a fierce, liquid heat. Deep within the earth's crust, in hidden chambers of unimaginable pressure, molten magma gathered. It moved not like a river of water, but like a slow, glowing river of fire. And over millions upon millions of years it cooled. So slowly, so patiently, it crystallized into the familiar stone we know. Every single grain of quartz and feldspar you can see in a piece of granite once shimmered in a molten glow, before solidifying forever in the deep, silent darkness. So the next time you run your fingers over a granite countertop, or rest your hand on a granite monument, you are touching the cooled remains of that ancient fiery flow, a moment frozen in time. Many of the world's great landscapes, from the sheer cliffs of Yosemite to the rolling highlands of Scotland, were shaped by these immense bodies of granite, rising and solidifying far below the surface before being lifted up for us to see. That stone holds within it the very patience of the planet itself. A quiet reminder that what appears so solid and eternal today was once liquid light. And yet, in this world of slow, patient creation, there are moments of astonishing speed. Diamonds, for instance, can sometimes form in a geological heartbeat. Most diamonds, it is true, take billions of years to grow deep within the mantle, born from simple carbon, crushed and heated beyond all imagination. But nature can be unpredictable. A very calm, soft, and soothing voice, slow-paced, with gentle intonation, designed for relaxation and meditation. Under the most extreme and sudden pressures, carbon can rearrange itself into a diamond almost instantly. These sudden, violent transformations happen miles and miles beneath the surface, where temperatures are hotter than molten metal, and the pressures exceed anything we could ever hope to replicate for long. From this crucible of fire and force, volcanic eruptions can bring these gems racing upward. They travel through narrow pipes of rock called kimberlites, carrying a story from the very depths of Earth's creation, delivered to the surface in a geological instant. Every diamond you have ever seen, no matter how small, once existed in a darkness and heat so fierce it could melt steel. Whether it was formed slowly or in that geological heartbeat, each crystal captures a single, extraordinary moment when ordinary carbon became something rare, something beautiful. They are nature's perfect record of transformation, born from unimaginable chaos and pressure, rising toward the light through the very bones of the planet. This constant transformation is happening right now, and on a scale that can be hard to comprehend. Some mountains, for instance, are still rising faster than your own fingernails grow. We see them as ancient and eternal, monuments of stillness against the moving clouds, but they are alive with movement. Deep beneath the surface, the immense tectonic plates of the Earth's crust continue to push and collide, forcing rock upward, inch by patient inch. In the Himalayas and parts of the Andes, this slow, silent collision is still at work, lifting the world's highest peaks just a little bit higher every single year. It is a strange and beautiful thought that these giants are not finished. They are still reaching for the sky. A very calm, soft, and soothing voice, slow-paced, with gentle intonation, designed for relaxation and meditation. What feels so solid and permanent is, in truth, part of an endless and delicate cycle of uplift and erosion. While the forces below are building, the forces above are wearing away. Wind, water, and ice work tirelessly, tearing the mountains down, grain by grain, while the deep, hidden engines of the planet just as tirelessly rebuild them. It is a rhythm that has played out for hundreds of millions of years, a slow and steady breath. If you could speed up time, you would see a mountain breathe, swelling upward as the continents collide. The very stone you might stand on at its peak may have once rested on the quiet, dark ocean floor, carried skyward over epochs of unimaginable time. These giants remind us that our Earth is not a static object at all, but a world in constant, graceful motion, reshaping itself even as we sleep. And this movement is not just vertical, it is horizontal. The ground beneath us is not fixed. Entire continents float like vast, silent rafts upon a hidden sea of molten rock. This can be a difficult idea to hold in your mind, but it is the fundamental truth of our world. Beneath the thin, fragile crust lies the mantle, a region so incredibly hot that solid rock behaves like an unbelievably slow-moving liquid, like honey in the deep cold. And the continents, our homes, simply rest on this flowing mantle, as enormous rafts of rigid stone, drifting across it through deep time. This is where our sense of place, our idea of a permanent home, becomes a beautiful illusion. We draw maps with hard lines. We build nations with firm borders. We think of our place in the world as a certainty. But all those lines are drawn on surfaces that are forever in motion. They slide, they collide, and they separate at a rate of only a few centimeters per year, a pace as slow as your hair grows, a speed so gentle it is completely invisible to us. Yet, over millions of years, those tiny movements reshape the entire face of the planet. Oceans open up and close again. Mountain ranges rise where there was once a shallow sea, and entire climates are transformed. The continents we know are travelers on an endless journey, though that journey is imperceptible to us. This slow, silent drifting is what once united all the land on Earth into the supercontinent Pangaea. And it is the very same force that will, one day, in a future so distant we cannot imagine it, bring all the continents together again. We are all passengers on these vast drifting plates, carried across geological seas without ever feeling the slightest hint of motion. This grand drifting is what once united all the land on Earth into the supercontinent. And it is the very same force that will one day, in a future so distant we cannot imagine it, bring all the continents together again. We are all passengers on these vast drifting plates, carried across geological seas without ever feeling the slightest hint of motion. This grand journey is part of an even more profound cycle, for the Earth's surface is constantly recycling itself through the engine of plate tectonics. Nothing you see on the planet's surface is permanent. The continents and the seafloors we map today are just one frame in an endless film of destruction and renewal. It is the planet's own way of staying young, of shedding its old skin. Where the great plates collide, mountains rise in a slow, crumpling embrace. Where they move apart, new ocean crust is born as molten rock wells upward from the depths to meet the cold sea. And in other places, one plate will dive gracefully beneath another, sinking back down into the mantle where it melts to become part of the earth once more. Every grain of sand, every cliff face, every volcanic plain is just a temporary traveler in this great planetary cycle. Our Earth is the only world we know of that recycles itself so completely, using the slow, quiet power of its internal heat and gravity to keep its surface forever young and alive. The planet's skin is never truly still, but forever shedding and remaking itself in a quiet, graceful motion that cradles all life. And we can see this process of creation happening right now, in the grandest of scales. High above the clouds, the Himalayas continue to rise. Their growth began around 50 million years ago, a time impossibly distant to us, yet recent in the life of the planet. It was then that the tectonic plate carrying India collided with the great Eurasian plate, crumpling the crust between them like a piece of folded fabric. And that collision, that slow, unimaginably powerful embrace, is still happening. It is pushing the mountains upward by just a few millimeters each and every year. The majestic peaks may appear timeless and unchanging against the sky, but their summits are still climbing, still reaching, even as the patient forces of wind and glaciers carve them down. Every tremor you might hear about in that region, every deep and distant earthquake, is just a whisper of that immense pressure still at work deep within the earth. These mountains are not relics of a distant past. They are the living, breathing result of an ongoing collision that began long before the first humans ever existed. The same colossal force that built Mount Everest continues to reshape the land beneath the feet of millions of people. It is a quiet drama that defines the very borders of nations. India, China, Nepal, lives and cultures shaped by a geological process that is utterly indifferent to them. In their silent, steady rise, the Himalayas remind us that the Earth's power is patient. It is relentless, and it is always, always in motion, sculpting entire continents as easily and as gently as a potter shapes clay. And that motion is everywhere. It is a truth that is both simple and profound. The continents themselves drift as fast as your hair grows. Imagine that for a moment. If you were to measure the movement of a continent, it would advance about as quickly as your hair lengthens in a single month. Yet over the vastness of geological time, that tiny, imperceptible pace reshapes the entire face of our planet. The continents slide silently on top of the mantle, carried by enormous convection currents deep within the earth. Great, slow-moving rivers of heat that have churned for billions of years. Because of this movement, the Atlantic Ocean grows a little bit wider each and every year, while the Pacific Ocean slowly shrinks. It is a planetary balancing act. In millions of years, the familiar maps we rely on will be completely unrecognizable. This slow, inexorable drift is what connects the fossils of ancient creatures found oceans apart. It is the quiet explanation for why mountain ranges on separate continents seem to share the exact same origins. The ground feels solid beneath us. It feels permanent. But it is part of a grand and restless voyage that has never, ever stopped since the planet was born. And this journey leads to one of geology's most beautiful secrets. Beneath the waves of our oceans lies a hidden world that is in a state of constant renewal. For while the continents hold rocks that are billions of years old, the seafloor is surprisingly, wonderfully young. Along the great mid-ocean ridges, those vast, unseen mountain ranges, molten rock constantly rises from the mantle. It cools in the dark, cold water and forms new crust that slowly spreads outward. As it drifts away from its birthplace, it eventually sinks back into the mantle at deep ocean trenches, where one plate slides gracefully beneath another. This perfect, elegant recycling system means that no ocean crust ever lasts longer than about 200 million years, a fleeting moment in the long, deep history of the Earth. The continents, by contrast, are the ancient survivors. They have floated above this cycle of destruction and rebirth for eons. They are like ancient libraries, holding the planet's oldest stories in their deepest rocks. The ocean floor, however, is a fresh page, constantly being rewritten. If you could watch our planet over time, you would see the oceans form and then vanish, with the gentle rhythm of a long, slow breath. The seafloor is the planet's heartbeat, renewing itself endlessly, a quiet reminder that even in the deepest, darkest, most mysterious places on Earth, the world is alive with motion and with change. And this young, ever-renewing ocean floor holds one of the planet's most elegant secrets. A story written in a language we have only recently learned to read. Across the vast, dark plains of the ocean floor, the rocks are patterned like a perfect barcode. These alternating magnetic stripes, invisible to the naked eye, mark the countless times in Earth's history when the planet's magnetic field has reversed direction, with north and south swapping places. It is a breathtakingly simple and beautiful recording system. As new crust is born at the mid-ocean ridges, tiny minerals within the molten lava align themselves with the planet's magnetic field. Like trillions of invisible compass needles, all pointing in the same direction. Before the lava cools and hardens into stone, that direction is locked in forever. Then, perhaps hundreds of thousands of years later, the magnetic field flips again. The next band of new crust that forms at the ridge will lock in the opposite direction, creating another stripe in the code. By reading these stripes, by towing sensitive instruments across the surface of the sea, scientists can trace the history of these magnetic flips stretching back for tens of millions of years. This discovery, this reading of the Earth's secret barcode, was one of the final definitive keys that proved the theory of plate tectonics, showing without a doubt how the sea floor spreads outward from the ridges over immense spans of time. Beneath the silent, crushing pressure of the oceans lies not chaos, but a perfectly ordered record of the planet's invisible forces, written in stone by magnetism, by heat, and by the slow, rhythmic pulse of geological time. So, when molten rock cools on the surface of the Earth, something truly extraordinary happens. The rock itself becomes a natural magnet. Those tiny particles of iron and nickel within it align themselves with the planet's magnetic field. And once the lava hardens, those directions are frozen in place, preserving a perfect snapshot of the magnetic field's orientation at that one specific moment in time. It is the Earth creating its own memory, its own archive. Scientists study these natural magnets to map the shifting history of the Earth's poles. Every reversal, every slow wandering of magnetic north is captured in stone, frozen as the planet's molten skin solidifies into a permanent record. These magnetic fingerprints are how geologists finally proved that the continents do drift, and that the seafloors are indeed spreading. It is a quiet, profound discovery that in every volcanic rock lies a silent record of the Earth's magnetic pulse, whispering clues about ancient directions and the invisible forces that shape the very space around our world. The planet's memory is magnetic, written in the iron heart of stone itself. And this process, this writing of history, is all powered by fire. Every volcano on Earth, whether it is on land or deep beneath the sea, connects to a hidden magma chamber far below the surface. Far beneath the calm fields and sleeping mountains, each volcano has a heart that beats with molten fire. These underground chambers of magma are vast, unimaginable reservoirs of liquid rock, and they are the engines that feed the eruptions that can reshape entire landscapes and even change climates. Some of these chambers are small and shallow. Others are immense and deep, reaching far down beneath the Earth's crust. They are not just pools of liquid. They are complex, evolving systems. Inside them, over thousands of years, crystals slowly form, gases rise and gather, and the pressure builds and builds and builds until the rock above can no longer hold it back. Then, with a staggering and elemental power, the chamber vents its fury through cracks and fissures, pouring lava and ash across the world above. And then, between these dramatic eruptions, the hidden reservoirs remain quiet, slowly refilling and evolving once more. A very calm, soft, and soothing worlds, like a tree. Modern technology allows scientists to glimpse their shapes, using seismic waves like a form of ultrasound for the Earth, mapping these hidden worlds of fire. Each volcano is just one small part of this deep, breathing network. A quiet reminder that beneath all the stillness of our world, there are vast, glowing seas of molten stone, waiting patiently below. Not all eruptions are the sudden, explosive moments in time that we see in our minds. Some are patient and utterly relentless, flowing for ages that are far beyond human imagination. When great plumes of magma rise from deep within the mantle, the result can be a flood basalt, a vast, silent outpouring of lava that continues for hundreds of thousands of years. It is not a mountain erupting, but the land itself. Fissures miles long open up and spill rivers of fire across the world. These eruptions can bury entire regions, entire countries, beneath miles of solid, dark rock. The Deccan traps in India and the Siberian traps in Russia are the enormous, silent relics of such ancient fire. During their long reign, they released enough gas and heat into the atmosphere to fundamentally alter the planet's climate and to change the course of life itself. These were not singular events, they were eras of fire. Standing on one of these hardened lava plains today, it is difficult, almost impossible, to imagine the molten rivers that once stretched to every horizon. A sea of liquid stone, glowing under a hazy, primeval sky. They remind us that sometimes the earth reshapes itself, not with sudden violent explosions, but with the slow, quiet, unstoppable rhythm of fire, spreading endlessly beneath the open sky. And if you could drain the oceans, you would see that this same dark rock forms the very foundation of the deep. If you could walk across the bottom of the sea, every single step would land on basalt, a dark, heavy rock born of fire. It forms when molten material from the mantle erupts all along the mid-ocean ridges and cools almost instantly in its contact with the cold, deep seawater. The result is a vast and unbroken crust of basalt, stretching across the entirety of the ocean basins like the planet's silent armor. Unlike the lighter granite rocks of the continents, basalt is rich in iron and magnesium, which gives it its deep, dark color and its considerable weight. Its solid layers are continually renewed as the seafloor spreads outward, while the old sections, far from the ridge, sink back into the mantle and melt once more. Every single square inch of the ocean floor has been part of this endless, graceful cycle of creation and destruction. Beneath the waves, in the crushing dark, the basalt holds the history of Earth's most patient and powerful movements, layer upon layer of cooled magma, forming the quiet foundation of all the world's oceans. And in that deep, dark world, the lava freezes in shapes of strange and gentle beauty. When lava erupts beneath the ocean, it cools so incredibly fast that its outer layer hardens instantly, while the molten rock inside still pushes from within. This strange and wonderful process creates rounded, bulbous shapes that resemble soft pillows or giant bubbles stacked one upon the other. These smooth, flowing formations, called pillow lava, can cover entire stretches of the seafloor. Each pillow is a perfect snapshot of fiery motion, frozen in an instant, a permanent record showing how molten rock and cold seawater dance together in the deep. When explorers find pillow lava on dry land, high in the mountains, it tells them a clear story, that the area they stand on was once deep, deep underwater. The sight of it is eerie and beautiful, as though the stone itself still remembers the moment it flowed like liquid, before being sealed forever by the sudden, deep chill of the sea. These shapes are geological sculptures, shaped by time and temperature, proof that even in the dark, crushing depths of the abyss, the planet's creative forces are always alive and always at work. In moments of explosive eruption on land, lava can cool so rapidly that crystals have no time to form at all. The result is obsidian, a natural volcanic glass that gleams with a dark, mirror-like beauty. It is smooth, sharp, and deeply reflective, formed when molten rock meets cold air or water and solidifies in an instant. For thousands of years, our own ancestors prized it for its perfect, razor-sharp edges, crafting blades, tools, and ornaments from this gift of the volcanoes. Yet behind its mirror-like surface lies a story of the most extreme and sudden change. Molten fire arrested mid-motion. Heat transformed into fragility. Obsidian breaks easily, but along the break it reveals stunning curved patterns called conchoidal fractures, as if each fracture still remembers the liquid flow of the original lava. This glassy rock stands as one of geology's most dramatic contrasts, born in unimaginable violence, yet perfectly still, fragile, yet ageless. It is a piece of fire, caught forever in the silent stillness of stone. And sometimes the stories trapped in stone are not in the substance of the rock itself, but in the spaces between. Trapped within the tiniest, most insignificant hollows of ancient rock, scientists have discovered microscopic bubbles of air that have survived for millions of years. These preserved pockets are perfect time capsules, sealing the chemical signature of the atmosphere from ages long, long past. Imagine holding a piece of cooled lava and knowing that inside it is a breath of air from the time of the dinosaurs. It is a thought that is almost too vast to hold. By carefully crushing these rocks in a vacuum, scientists can release this ancient air and study it. They can learn what gases once filled the skies, how much oxygen existed, how much carbon dioxide warmed the planet, and how volcanic activity, or life itself, changed that delicate balance over eons. Some of these bubbles were formed in cooling lava. Others were trapped within sediments or ancient deep ice. Each one, every single one, contains an echo of an ancient breath, a ghost of the air that once surrounded early forests or giant reptiles, or even the very first life to ever breathe. To hold such a rock is to hold a fragment of a vanished sky. This isn't just a story about the past. It is a vital clue to our present and our future.
Understanding these ancient atmospheres helps us build models of our own changing climate, giving us a baseline from which to measure our own impact. It is a quiet, geological conversation that informs the decisions of nations, a whisper from deep time that helps us understand the fragile balance we live in today.
It is a delicate record of the ever-changing air that connects all living things across the long, unbroken history of the earth. And just as there are hidden worlds trapped inside stone, there are entire hidden worlds on the planet itself. There are mountains far higher than Everest, hidden quietly beneath the sea. Far, far below the sunlit surface of the oceans lie mountain ranges that completely dwarf the world's highest and most famous peaks. Along the mid-ocean ridges, immense chains of volcanic mountains stretch for tens of thousands of miles, circling the globe like a seam. These submarine ranges are mostly unseen, shrouded in eternal darkness and an immense crushing pressure. Yet they are among the most geologically active regions on Earth. Lava continually emerges from deep fissures, building new peaks and valleys in a slow, steady, silent motion. The tallest of these hidden giants, like Mauna Kea in Hawaii, when measured from its true base deep beneath the sea, surpasses even the great Himalayan summits. We see only its small final peak, the part that has managed to break through the surface of the water. But its true majesty, its true scale, is hidden. These are reminders that so much of Earth's true beauty and grandeur lies unseen, beneath the waves. Vast, silent kingdoms of rock that grow and shift in the darkness, shaping the world from below without ever receiving a single glimpse of the sun. And today, these hidden realms are the new frontiers. Nations are mapping these depths with robotic submarines, not just for the sake of science, but for the rare minerals and resources that are found there. A quiet geopolitical game is being played in the dark, a patient claiming of territory in a world most of us will never, ever see. Even here, in the deepest dark, the story of geology and the story of humanity are becoming one. At the very heart of the Pacific Ocean lies the Mariana Trench, a chasm so impossibly deep that if Mount Everest were gently dropped into it, its famous peak would still be submerged by more than a mile of dark water. The trench's deepest known point, the Challenger Deep, reaches nearly 7 miles beneath the surface, a distance almost the same as the altitude at which passenger planes travel high above the Earth. Down there, in that absolute blackness, the pressure is a force beyond our everyday comprehension. It is immense, crushing enough to flatten solid steel. For centuries, we believed it to be a place utterly devoid of life, a sterile dead zone. Yet, even in that crushing darkness, life endures. Strange, beautiful organisms glow with their own faint light in the black water, thriving among the fine, mineral-rich sediments. They have adapted to a world that no human could ever survive in. The trench marks a subduction zone, a place where one great tectonic plate slips gracefully beneath another and sinks back down into the mantle. So it is not just the lowest point on Earth. It is one of the planet's great engines of renewal. A place where the old crust goes to be reborn as new rock. It reminds us how small our visible world truly is, compared to the vastness that is hidden just below. It is a place of profound silence and profound transformation, happening constantly in a realm we will never truly know. And yet, you do not need to travel to these extreme depths to feel the planet's secret life. Even when the ground seems utterly, perfectly still beneath you, it is vibrating with the faint, steady murmurs of constant motion. All across the planet, thousands of tiny quakes ripple through the crust each and every day, far too small and too gentle for any human to detect. These micro-earthquakes release little bursts of energy as the Earth adjusts to the immense stresses deep below. They are the planet's quiet sighs. Scientists use incredibly sensitive instruments to record these whispers, creating detailed maps of shifting faults and the hidden flows of magma. Together, these tiny, unheard tremors form a background hum that never, ever ceases. It is the quiet pulse of a living planet. This ceaseless trembling is what tells geologists where faults are slowly creeping, where immense pressure is building, and where volcanic systems are gently stirring from their slumber. The complete stillness of our world is a beautiful illusion. Beneath every mountain, every forest, and every sea, the planet moves in countless small ways, sighing, cracking, and settling in slow, secret rhythms that carry the story of the Earth's restless, living heart. And sometimes that restless heart beats with a terrifying power. When the ground shakes with enough force, the landscape itself can change direction in an instant. During the most powerful earthquakes, the land can tilt or shift so abruptly and so violently that entire rivers are forced to reverse their flow. This rare and stunning phenomenon was recorded during the Great New Madrid earthquakes in the early 19th century, when witnesses watched in disbelief as sections of the mighty Mississippi River temporarily flowed upstream. The sudden movement of the crust can raise one side of a fault or drop another, creating natural dams or lowering entire valleys in a matter of moments. For a very calm, soft, and soothing voice, slow-paced, with gentle intonation. For a brief, terrifying time, the raw power of the Earth's internal forces can overcome the steady, constant pull of gravity that guides every single drop of water on its journey to the sea. When the balance finally returns, the rivers carve new paths through the changed and broken terrain. These moments reveal the sheer, unimaginable strength of geological motion, showing that even something as constant and as ancient as a river can be turned backward by the planet's deep and hidden forces. But not all of this motion announces itself with a roar. Not all tectonic movement results in quakes or destruction. Along certain sections of faults, the crust slides so slowly and so evenly that there is no noticeable shaking at the surface at all. This quiet, ghostly movement, known as fault creep, relieves the building pressure in small, continuous, gentle increments. It is completely invisible to anyone standing above, but it is measurable by instruments that can detect motion of just a few millimeters per year. Certain faults in California and Turkey move in this way, gliding smoothly and silently, while neighboring sections remain locked and tense. This subtle dance between tension and release is part of the planet's constant balancing act. Even without drama or noise, the ground beneath us is shifting, whispering in slow motion as the Earth adjusts itself, grain by patient grain, across the ages. At the very center of our planet, far beyond our reach, lies a sphere of molten and solid metal under pressures that are truly beyond all human comprehension. The temperatures there, in that hidden, secret heart, reach more than 9,000 degrees Fahrenheit, rivaling and even exceeding the visible surface of the sun itself. Very calm, soft, and soothing voice, slow-paced, with gentle intonation, designed for relaxation and meditation. This immense, ancient heat is the leftover energy from the Earth's violent formation, combined with the constant, slow decay of radioactive elements deep inside. Though we will never see it directly, this core is the engine that drives everything. It powers the volcanic eruptions that build new land, and it generates the magnetic field that shields all life from the harsh radiation of space. Its motion churns like a vast planetary dynamo. The inner core, a sphere of solid iron, rotates slightly faster than the rest of the planet above it, while the outer layer flows around it in liquid form. This hidden furnace is the beating heart of the Earth, the ultimate power source that keeps our world alive with movement, with warmth, and with a deep, quiet resilience. And yet, this fiery heart holds a secret that sounds like a beautiful contradiction. Far beneath the crust, where rock glows with an inner heat and pressure,
Scientists have found minerals that contain vast, truly vast amounts of trapped water. These discoveries suggest that an entire ocean's worth of water, and perhaps much, much more, may exist hundreds of miles below the surface. This water is not flowing freely in some great cavern, but is bound within the very crystal structures of the rock itself. It is a part of the stone. If it were ever released, this hidden reservoir could fill the world's oceans multiple times over. It is not a sea in any familiar sense, but a deep, secret storage of the very same substance that sustains all life.
It is thought that the slow, steady movement of the tectonic plates may carry water downward into this hidden realm, only for that same water to return to the surface millions of years later through volcanic eruptions and rising plumes of molten rock. A deep planetary water cycle we are only just beginning to understand. This unseen process could be one of the fundamental keys to understanding why Earth has oceans at all, and why our planet is so uniquely suited for life. It is a profound and comforting thought that even in the deepest, hottest stone, water finds a way to endure, waiting patiently inside the planet's mantle for eons. And from this world of deep pressure and hidden water, sometimes, under the rarest of conditions, the planet creates a place of impossible beauty. In the quiet, absolute darkness beneath the deserts of northern Mexico lies a cathedral made of pure crystal. The cave of the crystals, buried deep within a working silver mine, holds translucent gypsum blades that stretch more than 30 feet long. Each one took hundreds of thousands of years to grow in perfect, undisturbed stillness, nourished by the hot, mineral-rich water that once completely filled the chamber. When miners eventually drained the water away, the growth stopped, and the crystals remained, gleaming like frozen moonlight in the hot, humid air. Entering the cave is like stepping into another world, one built not of rock and fire, but of slow, delicate, and absolute perfection. The conditions required to create such formations are almost impossibly rare. A perfect, sustained balance between heat, mineral saturation, and time. These enormous crystals remind us that even the hardest materials on Earth can move and grow and change, given patience enough. They are the planet's most beautiful expression of stillness, art shaped by nothing more than time itself. The air is so hot and thick with moisture that no one can stay inside for long. Yet, for a few brief moments, explorers have walked among these shining walls of translucent stone. It is a vision of geological art, created not by hands, but by time, by water, and by the quiet, patient chemistry of the earth itself. In other regions, where thick layers of ancient salt lie buried deep beneath heavier rock, a strange and powerful phenomenon can occur. Over millions of years, the salt, which is less dense than the rock above it, begins to flow upward, pushed by the immense pressure from the surrounding layers. Although it is a solid, salt behaves like an incredibly viscous fluid under great stress. It rises through the rock above it, bending and breaking the layers, creating vast dome-shaped structures that can reach miles in height. They are like slow-motion explosions that take millions of years to unfold. From the surface, they might appear only as gentle swells in the landscape, but beneath, they are vast pillars of slow, silent movement, reshaping the earth from below. These patient rising pillars are what geologists often look for when searching for oil and gas, which can become trapped along their sides. Each one tells the story of an ancient sea that evaporated long, long ago, leaving behind minerals that are still, to this day, climbing slowly and silently back toward the sky. What looks like a fallen tree turned to stone is something far stranger and far more delicate. When a tree is buried by volcanic ash or fine sediment, a slow and magical transformation begins. Minerals, carried by groundwater, seeping through the earth, find their way into its cells. And then, over thousands and thousands of years, each tiny, delicate structure of the wood is replaced, molecule by patient molecule, with quartz. The process is so perfect, so slow, that it preserves every ring, every knot, and every fiber in silent, intricate detail. The result is a fossil that still looks exactly like wood, but it feels cold and heavy and ancient to the touch. Sometimes other trace elements in the water will paint the stone in soft, beautiful hues, reds and yellows and greens, creating a natural, quiet artwork within its grain. Holding a piece of petrified wood is like holding a memory that has been made solid. A living, breathing thing transformed into crystal by the impossible patience of time. It is a testament to the fact that even in burial there can be a kind of rebirth, a new form of beauty. It is nature's quiet way of saying that nothing truly, completely disappears. It only changes form, keeping the story of life locked forever within the heart of stone. And in another form of transformation, entire forests from a time long past are still with us. Coal, that simple, dark rock, began its life as ancient forests trapped in swampy, forgotten worlds. Long, long before any humans walked the earth, vast, silent, tropical forests covered so much of the land. When these great forests died, their fallen trunks and leaves and ferns sank into oxygen-poor swamps,
where the normal process of decay slowed almost to a stop. Layer upon layer of this plant matter built up, pressing down under its own immense weight.
A very calm, soft, and soothing voice, slow-paced with gentle intonation, designed for relaxation and meditation. And over millions of years, the gentle heat and steady pressure of the earth transformed that buried organic material into coal, a dense, dark rock made of concentrated carbon. Within every single piece of it lies the captured energy of sunlight from a prehistoric sky. Burning coal releases that ancient sunlight once more, a ghostly return of energy stored for eons in the dark. It is a strange and powerful connection to a world we can never see, a world of giant insects and strange towering ferns, a world that breathed a different air. The process that created it tells a story of transformation where life became stone and sunlight became fuel. Every lump of coal we have ever held carries the faint, ghostly imprint of those ancient forests, the very breath of a vanished world, condensed into dark, glittering veins that run beneath our modern one. And the oceans, they hold their own ancient sunlight. The oil that powers our modern world comes from the buried remains of ancient plankton. Long before the dinosaurs ever roamed the land, the ancient oceans were filled with microscopic life. When those trillions upon trillions of tiny organisms died, they sank to the quiet seafloor and mixed with the mud, forming thick, rich layers of organic sediment. And over millions of years, the immense weight of the ocean above pressed them deeper and deeper into the crust, heating and compressing them until their carbon-rich remains transformed into liquid hydrocarbons. Trapped within porous rock, these ancient molecules became the oil that we seek out with such determination. Every single drop that we burn once drifted through a primordial sea, gathering sunlight through the simplest and most humble forms of life. In a way, the energy that fuels our world is the sunlight of Earth's deep past, stored for an eternity beneath miles of silent stone. The story of oil is not only one of geology, but of biology, of chemistry, and of time, woven together in the quiet, absolute darkness below the surface, waiting patiently for its discovery. And from the grandest stories of mountains and forests, we come to the smallest of things. Every single grain of sand on a beach tells the story of a vanished mountain. Each tiny, glittering grain was once part of something far, far greater. Long before it rested on a beach or in a silent desert dune, it was part of a towering mountain or an ancient bedrock plain. Over millions of years, wind, water, and ice ground that great rock down to its smallest possible pieces, carrying them on a long journey across rivers and seas. A single grain might have tumbled through glaciers, flowed down deep canyons, or drifted for centuries across oceans before finally coming to rest. Under a microscope, its shape and its composition reveal the kind of rock it came from and the long, long journey it took. Some grains still shine with fragments of quartz from ancient continents. Others are dark volcanic shards from fiery eruptions long, long past. Every handful of sand is a storybook of time, a collection of broken worlds reduced to glittering fragments that will one day be pressed back into stone and start the entire cycle all over again. In a few rare and quiet deserts around the world, the shifting of the sand dunes creates a deep, resonant hum that can last for minutes at a time. These singing dunes, found in places like Morocco, Chile, and the Arabian Peninsula, produce notes so pure and so low that they sound like the very voice of the earth itself. The sound comes from countless grains of sand, sliding and colliding in perfect flowing unison, vibrating at a frequency that is somewhere between a cello's lowest tone and a soft, distant, thunderous roar. Scientists believe the grains of sand must be nearly uniform in their size and perfectly, utterly dry for this strange and beautiful effect to occur. Travelers who have heard it describe the experience as haunting, as though the dunes themselves are breathing or speaking in a language older than words. Ancient peoples often treated these sounds as mystical, believing they came from hidden spirits or the gods of the desert. And in a way, perhaps they were right. It is not spirits, but it is physics and friction working together on a colossal scale, turning the vast empty landscape into a natural instrument that sings the slow, patient, and beautiful music of the shifting earth. And from the desert, we travel to the shore. Along certain coastlines, the sand beneath your feet was not carved from stone at all, but was built ever so slowly by life. Over centuries, the shells of countless tiny marine creatures, like mollusks and foraminifera, have been broken down by the waves into fragments so fine they resemble powdered ivory. These biological sands can gleam a brilliant soft white under the sun, or shimmer with a gentle pink from the dust of crushed coral, or even glow with a pale gold from the remains of microscopic algae. Each and every grain is a fragment of something that once lived, a tiny piece of the ocean's past, returned gently to the shore. Walking along such a beach is like stepping through the soft, quiet ruins of invisible kingdoms, where the endless work of waves and tides has turned the delicate architecture of life into a soft, shifting tapestry. The world's most famous white beaches, like those in the Bahamas and the Maldives, are living evidence that time and biology can build a landscape of profound beauty, just as surely as rock and fire can. It is a different kind of geology, a geology not of erosion, but of accumulation, not of mountains being worn down, but of life building up. And not all beaches shimmer with gold or white. Some are painted in the earth's more dramatic colors. Some are black from cooled lava, others a soft green from olivine crystals, pink from coral, or even a deep rusty red from eroded volcanic rock. Each color tells a clear and simple geological story about its source and about the forces that shaped it. Black sands often line volcanic islands, formed in an instant when molten lava met the cold sea and shattered into billions of tiny, glassy fragments. Green beaches appear in rare places, where olivine, a mineral from deep within the Earth's mantle, is brought to the surface and washes ashore. Pink hues come from the crushed shells and coral mixed with white sand, while red sands are tinted by iron-rich rock that has been slowly oxidized by the air over time. Walking these colorful shores is like wandering through the personal palette of the planet itself, a quiet art gallery where the earth shows its true colors. Every wave gently rearranges these tiny grains that carry the memory of fire and water and time, blending the world's elements into a natural art that shifts and glows and changes beneath the ever-changing light of the sky. And from the smallest grains, we now turn to the largest sculptors, glaciers. A glacier seen from a distance seems perfectly still, a monument of ice. Yet it flows. Over centuries, the immense weight of accumulated snow compresses into a dense, heavy ice that begins to slowly slide downhill, reshaping everything in its path. These frozen rivers grind against the mountains with unimaginable force, scraping out valleys, polishing stone, and carrying debris for miles and miles. When they finally retreat, they leave behind a world transformed. Wide, U-shaped valleys, scattered boulders left in impossible places, and shimmering clear lakes that fill their abandoned paths. The fingerprints of glaciers can be found on nearly every continent, from the smooth granite domes of Yosemite to the deeply carved fjords of Norway. Even now, the world's remaining glaciers continue their slow, patient work, grinding ancient rock into a fine dust that drifts on the wind. They are the sculptors of continents, the great artists of time and temperature, shaping the land grain by patient grain. In their quiet, cold persistence lies a reminder of the planet's delicate and powerful balance, where even the coldest forces flow with a power strong enough to change the entire world. Although glaciers usually creep along at the pace of mere inches per day, a few special rivers of ice flow so quickly that their movement can be observed within a single afternoon. These fast-moving glaciers surge when meltwater lubricates the ground far beneath them, reducing the friction and allowing massive, heavy sheets of ice to slide rapidly forward. In Greenland and in parts of Alaska, scientists have documented glaciers racing ahead at surprising speeds, their fractured surfaces groaning and cracking as they go. From a distance, the motion seems impossible, a violation of the laws we think we know. Solid ice behaving like liquid stone. And this has real meaning for us today, a quiet warning from the ice itself. It changes how we see our own world, how we measure the melting of ice and the rising of the sea. These surges remind us that the planet's changes are not always slow and linear. Sometimes they are sudden and dramatic. Yet even in this speed, there is a slow and powerful grace. This movement carries enormous power, reshaping entire valleys and transporting rock by the ton. As they surge, they also remind us that even in their frozen stillness, glaciers are alive, deeply and profoundly alive with motion. To witness one in movement is to see time itself accelerate. The slow, ancient rhythm of the earth condensed into a visible, breathtaking surge. And deep beneath the surface of a glacier, where the pressure is immense and the temperatures hover just below freezing, ice stops behaving like a solid at all. Instead, it flows. Not quickly, but slowly and continuously, folding and bending just like honey poured in slow motion. The very crystals within the ice deform and slide past each other, allowing the entire colossal mass to creep downhill. The very crystals within the ice deform and slide past each other, allowing the entire colossal mass to creep downhill. This is what gives glaciers their fluid grace, their astonishing ability to carve mountains and shape valleys over tens of thousands of years. Under the right conditions of heat, pressure, and time, even solid rock can behave this way, flowing over geological timescales. Watching ice deform under pressure in laboratory experiments reveals how matter itself can blur the line between solid and liquid. What appears to us as unyielding and rigid becomes supple and soft with enough time and enough weight. The planet's greatest transformations often happen not in sudden, violent bursts, but through the quiet, relentless persistence of materials, learning ever so slowly to move under pressure. And from these grand continent-shaping forces, we can turn to the smallest, most delicate traces of the past. Sometimes the most fleeting moments can survive in stone. On slabs of ancient sedimentary rock, scientists have found the delicate, perfect impressions of raindrops that fell onto soft mud long before humans ever existed. Each tiny, perfect crater records a single moment in time, a quiet storm that passed across a primeval landscape, its droplets scattering across a world filled with strange alien plants and the very first forms of early life.
Within seconds of falling, the marks were buried by new layers of fine sediment, sealing them in darkness until the rock hardened around them. And then, millions of years later, when the surface is exposed once more to the wind and the sun, it reveals a perfect imprint of the weather from a vanished age. These fossilized raindrops are so profound because they are so simple. They remind us that even the most fleeting, insignificant moments can last forever when they are preserved by perfect chance.
In a very calm, soft, and soothing voice, slow-paced with gentle intonation, designed for relaxation and meditation. In a single stone, we can read the touch of a storm that ended hundreds of millions of years ago, its gentle rhythm still visible on the ancient stone pages of the planet's memory. For centuries, we believed that fossils could only capture bones and shells, the hard, durable remains of ancient creatures. But discoveries over the past few decades have revealed something truly astonishing. Under the rarest of conditions, even the most delicate tissues can survive. In certain kinds of rock, scientists have found the impressions of skin, of muscle, and of feathers, and sometimes even traces of the pigment that show the original vibrant colors of dinosaurs and ancient birds. These fossils form when mineral-rich water seeps through the remains before decay has a chance to destroy them, replacing the organic molecules one by one with stone. The result is a moment of life turned into perfect sculpture, preserved in every intricate detail. Some of these fossils even retain microscopic structures that hint at how these creatures moved, how they breathed, and how their skin or feathers shone in the sunlight of their time. To hold such a fossil is to bridge entire worlds, feeling the quiet echo of warmth and color from beings that vanished hundreds of millions of years ago. It is geology allowing us to see not just the shape of life, but its substance. Long before any animals or plants evolved, simple, humble microbes built layered, dome-shaped structures in the warm, shallow seas. These formations, called stromatolites, are the planet's oldest known living fossils. They were created by vast mats of bacteria that trapped and bound tiny grains of sediment, forming domes that slowly, patiently grew toward the sunlight. Some of the most ancient examples are more than 3.5 billion years old, making them among the very earliest evidence of life to be found anywhere. It is a form of life so simple, it is almost one with the rock itself, a living stone. And, remarkably, stromatolites still exist today. In a few remote and special places, like Shark Bay in Australia, these microbial communities continue their slow, rhythmic growth, just as they have for billions of years. Looking at one is like peering directly into the dawn of biology, a time when the very first cells began to shape the planet. They are a quiet, profound testament to the power of persistence. They remind us that life's incredible story began not with speed or motion or complexity, but with patience. Layers upon layers of living film, turning light, water, and time into the very foundation of everything that would follow. And that foundation was tested in the most extreme way imaginable. Around 700 million years ago, our planet nearly froze solid. It was a period now known as Snowball Earth. Ice, thick and vast, stretched from the poles all the way to the equator, sealing the oceans under a miles-deep frozen crust and reflecting the sun's light back out into space. It is believed that a combination of volcanic activity, shifts in atmospheric gases, and changes in solar energy all combined to trigger this global deep freeze. For millions of years, the Earth remained a vast, silent, gleaming white world of ice, its surface shining faintly beneath a dim and distant sun. Yet, even in this frozen silence, life endured. It hid in small pockets of liquid water deep beneath the glaciers or near the warmth of volcanic vents on the seafloor. Life found a way, as it always does. And eventually, it was those very volcanoes that saved the world from its icy prison. During the depths of this global freeze, volcanoes continued to erupt, patiently pumping carbon dioxide into the air for millions of years. With the vast oceans sealed beneath a cap of impenetrable ice, this gas could not dissolve into the water as it normally would. So it simply built up in the atmosphere, layer by patient layer, slowly, relentlessly, trapping more and more heat. When the ice finally began to melt, the process accelerated with incredible speed. Dark, exposed rock and water absorbed the sunlight that the ice had once reflected, amplifying the warming effect. Within a geological blink of an eye, the planet shifted from a frozen white ball to a world of steaming blue-green seas once more. This dramatic world-spanning thaw may have helped trigger an explosion of new, more complex life. The return of liquid oceans, now rich with minerals from the long-frozen land, unleashed floods and erosion and perhaps even chemical changes that nourished the patient, waiting life. The Snowball Earth stands as one of the greatest and most dramatic transformations in all of planetary history. A near death and a powerful rebirth, a story written in ice and in snow. In a way, the volcanoes saved the planet. Their quiet, fiery persistence beneath the ice kept the Earth's climate alive. And what was once an age of absolute silence became an age of renewal, proving that even in the planet's darkest, coldest hour, fire and life were waiting patiently below. The air we breathe today, the clear, life-giving air that fills our lungs,
owes its very existence to the tiniest of organisms that lived billions of years ago.
These simple microbes, the ancestors of modern cyanobacteria, thrived in the shallow, sunlit seas of the young Earth, and they discovered a new and powerful trick. They learned to use sunlight to split water molecules, releasing pure oxygen as a simple byproduct. It was just their waste, a simple exhalation. Yet, over immense spans of time, their collective breath transformed the entire planet. It was perhaps the first time life didn't just adapt to the world, but actively changed it on a global scale. A quiet, slow-motion revolution, carried out by the smallest and most humble of living things. At first, this new oxygen did not fill the air. Instead, it reacted with the vast amounts of dissolved iron in the oceans, creating, in essence, rust. For millions of years, this rust settled in gentle, continuous layers on the seafloor, forming vast deposits of rust-colored rock. We see them today as banded iron formations, beautiful striped rocks of red and gray that shimmer with a metallic luster. They are the fossilized record of the exact moment the planet began to breathe. Each stripe in the stone is a heartbeat in the planet's great transformation, a quiet testament to a world that was slowly, inexorably rusting. Only after all the iron in the oceans was saturated did this new gas finally begin to fill the atmosphere, slowly turning it into the life-giving mixture that we depend on today. This event, known as the Great Oxidation, changed everything. It was a poison to much of the life that had existed before, but it allowed new, more complex cells to evolve, and eventually made possible the rise of plants and animals and us. Today, those same ancient iron formations are mined for the steel that builds our modern world. The frame of our cities, the bodies of our cars, all of it is a gift from the breath of those ancient microbes. Every breath you take is a connection to them. Their simple chemistry turned a barren world into a living one, paving the way for the forests, the oceans, and all that was to follow. And before that great change, before the oxygen filled the air, the Earth's oceans may have looked very different indeed. The water may have shimmered with strange and alien shades of red and violet, colored by ancient microbes that used molecules of sulfur, not oxygen, to capture the faint light of the young sun. These organisms thrived in the chemical-rich seas under a hazy orange sky, producing pigments that tinted the water with these strange and beautiful hues. Imagine it for a moment, a world of purple seas beneath a dim and silent sun. The signature of life experimenting with light, long before the age of forests or coral reefs or any creature that breathed the air we know.
As the new oxygen-producing bacteria began to release their waste into the world, these ancient purple oceans slowly faded away, turning to the familiar blue that we know today. The shift from a sulfur-based world to an oxygen-based one was one of the greatest and most profound transitions in all of Earth's history, altering everything from the chemistry of the atmosphere to the very color of the rocks. The rise of oxygen was a cleansing fire to that old world, but it was also the dawn of our own. This reminds us that even the most fundamental things we know about our planet, the blue of the sea, the air we breathe, are not constants.
They are chapters in a story of immense, slow, and beautiful change. The continents that we see today, the familiar shapes on our maps, are only the latest version of the Earth's face. In the vastness of deep time, entire mountain ranges have risen to touch the sky, and then have vanished so completely that no trace of them remains. Wind, water, and gravity, they work patiently, wearing down even the tallest and most resilient peaks, grain by silent grain. Over hundreds of millions of years, erosion can erase a mountain as easily and as completely as a wave can smooth a pebble on the shore. Sometimes the deep roots of these ancient vanished mountains survive as crystalline rock, buried far beneath newer layers. They are clues left behind for geologists to find, the quiet ghosts of a landscape that is long, long gone. Some of the oldest continental crusts on our planet, now reduced to flat, quiet plains, once bore enormous mountain ranges that would have dwarfed anything we know today. The planet is always rebuilding itself, and what seems so eternal and permanent to us is only a temporary sculpture in the ongoing, quiet art of geology. Every plain and every valley was once a summit, and every single stone you have ever held carries the ghost of a vanished mountain deep within its heart. And just as mountains are temporary, so are the continents themselves. Over the course of billions of years, they have gathered together and then drifted apart like slow-moving puzzle pieces on a vast planetary canvas. Driven by the immense patient heat rising from the mantle, the Earth's crust has folded, it has fractured, and it has rearranged itself again and again and again. Each great collision built new mountains. Each slow separation opened up new oceans. This process, known as the supercontinent cycle, has repeated itself at least half a dozen times in our planet's long, long history. When continents collide, rocks are buried deep and are reborn through the immense heat and pressure of the deep earth. And when they separate, new crust is formed in the gap between them, carrying with it the ancient shattered fragments of lost worlds.
The scars of these great migrations are visible everywhere if you know how to look. You can see them in the matching fossils and the identical rock patterns that are found on the opposite sides of our modern oceans. They are the quiet evidence of an ancient connection. The land beneath our feet is not fixed. It is not permanent. It is part of a restless, silent dance that never, ever ends. Proof that the ground we stand on has traveled far, carrying the history of countless ancient forgotten worlds within its deep foundations. And before Pangaea, the one great continent we all learn about in school, and even before the one that came before it, Rodinia, the Earth assembled and broke apart at least 6 times, forming vast supercontinents that drifted silently through the ages. Nuna, Columbia, Rodinia, Pannotia, and Gondwana are the names that geologists have given to these lost worlds. Their remains are now scattered all across the globe. When they existed, life was often microscopic, a simple film upon the rock. Yet their formation and their breakup shaped the very chemistry of the oceans and the atmosphere. Each breakup and each reunion altered the course of evolution, stirring the climate and shifting the deep, warm currents of the planet.
The continents we know today are just the pieces of those ancient sleeping giants, the survivors of a cycle that spans billions of years. To study them is to read the Earth's own autobiography, a story written across time, where even the land itself is temporary, and nothing stays whole for long. And Pangaea was only the most recent of these great gatherings. About 250 million years ago, nearly all of the land on Earth came together into a single vast supercontinent, which was surrounded by a single global ocean. This colossal landmass called Pangaea stretched from pole to pole, connecting regions that are now entire continents apart. Its deep interior was harsh and dry, far from the moderating influence of the sea, while its long coasts teemed with early reptiles and strange ancient forests. Over tens of millions of years, the heat building up beneath the crust created an immense pressure, until great cracks appeared, splitting the land apart once more. The Atlantic Ocean was born in this separation, and the continents began their slow, silent drift toward their modern positions. The identical fossils of plants and animals found on the opposite sides of that ocean are the silent, lonely witnesses to that ancient unity. Pangaea's breakup shaped our modern geography and our climate, setting the stage for everything that was to follow. It was not the first supercontinent, nor will it be the last. It was only one chapter in the Earth's endless, patient drift. Far beneath the quiet waves of the Pacific Ocean, the slow, immense movements of the tectonic plates are already setting the stage for the next great rearrangement of the Earth's surface. Geologists, using the data of this slow drift, can run the clock forward, and they predict that in 200 to 300 million years, the continents may once again converge into a new single supercontinent. The names they give these future worlds sound like science fiction: Amasia, Pangaea Proxima. But they are based on the real, measurable movements happening right now. Some models suggest the Pacific Ocean will close as Asia and the Americas drift slowly, inevitably together. Others imagine the Atlantic closing instead, drawing Europe and the Americas back toward each other into a final, mountain-building embrace. Though the final outcome is uncertain, the process itself is inevitable. The same invisible, powerful currents that tore Pangaea apart are still at work today, shifting the continents, inch by patient inch. To imagine the world that far ahead is to realize how truly temporary our maps really are. The lines we draw, the nations we build, the conflicts we wage over borders are all happening on a surface that is in a state of constant, graceful flux. The Earth is always, always remaking itself. And somewhere deep below us in the flowing mantle, the very first motions of the next supercontinent have already begun. And we can see this future being written in the present-day movements of our world. Far beneath the continent of Australia, the tectonic plate that carries it is slowly, silently gliding northward, at a pace of just a few centimeters each year. Over millions of years, this gentle, imperceptible motion adds up to thousands of kilometers. Eventually, Australia will collide with the islands of Southeast Asia, raising new, great mountain ranges and completely reshaping the coastlines we know today. Our satellites can track its yearly drift with astonishing and beautiful precision. The motion is powered by those deep convection currents in the mantle, where the ancient heat from the planet's core moves the vast sheets of rock above as if they were simple rafts on a molten sea. Though the movement is imperceptible to us in our daily lives, it changes everything over time. It changes maps and climates and even entire ecosystems. Coral reefs will grow where land once lay. Deserts will inch slowly toward the tropics. And someday, new mountain ranges will rise between the two colliding regions. The continent's slow, silent voyage north is one of the most graceful and powerful migrations on Earth, a quiet journey toward a destiny that is already written in the language of physics. And in another part of the world, a continent is not moving, it is breaking. Deep within East Africa, a great rift stretches for thousands of kilometers, marking the place where the continent is slowly but surely tearing itself apart. The volcanic activity, the constant earthquakes, and the thinning of the crust all reveal that a new ocean may eventually form there. The East African Rift is a visible reminder that our continents are never truly solid. They bend and they stretch like skin over a living, breathing body. In a few tens of millions of years, the region that now includes Ethiopia, Kenya, and Tanzania could separate completely from the rest of Africa, drifting eastward to become its own new landmass. Great lakes like Tanganyika and Malawi already fill the rift's deepest scars. They are the early, quiet clues to the ocean that will someday flood in. To stand on the edges of that great rift is to glimpse the very birth of a future continent. The process is slow, beyond all imagination. Yet it is happening right now, beneath our feet, shaping the world of tomorrow. The island of Iceland exists for a similar reason. It sits directly straddling the mid-Atlantic ridge, a great boundary where two tectonic plates are moving apart. Here, molten rock wells upward through a long tear in the Earth's crust, building new land as it cools in the cold northern air. The entire island is a dramatic, beautiful crossroads of fire and ice, with ancient glaciers resting right beside active, breathing volcanoes. The hot springs, the geysers, and the vast dark lava fields all testify to the restless, creative energy just below the surface. Every few years, new eruptions remind the people who live there that their homeland is still under construction. Iceland is a living, breathing experiment of creation, a place where the earth quite literally grows before our very eyes, balanced on the fine, sharp edge between the frozen North Atlantic and the molten heart of the planet itself. In the middle of the vast Pacific Ocean, a single, stationary plume of molten rock rises from deep within the mantle, punching through the crust to create volcanoes on the seafloor above. But the crust itself is not still. The great Pacific Plate is drifting slowly, majestically to the northwest. And so, as it drifts, each new eruption forms an island that eventually moves away from this fixed hotspot, allowing another island to take its place in a long, graceful procession. This process has created a beautiful dotted chain of islands and undersea mountains stretching for thousands of kilometers across the silent ocean floor. The youngest island, the Big Island of Hawaii, still glows with active lava flows. It is a world still being born. While the oldest islands, now far to the northwest, have been carried away from the fire and have been eroded by wind and waves into low, quiet atolls and reefs. By tracing this long chain, scientists can map the precise movement of the Pacific Plate over millions of years. The hotspot itself stays fixed in the deep earth, while the surface glides silently above it, leaving a perfect dotted record of time and motion. Each island is a single chapter in an ongoing story of creation, a story written in molten stone upon the moving canvas of the sea. And this same process happens on land. Beneath the deep forests and steaming geysers of Yellowstone National Park lies an immense reservoir of magma, one large enough to fuel one of the most powerful volcanic systems ever discovered on our planet. The park's steaming vents, its bubbling mud pools, and its dramatic clockwork eruptions of boiling water are all just gentle surface clues to the immense and restless heat that waits just below. Scientists monitor this region with the utmost care, mapping the hidden chambers of molten rock that stretch for dozens of kilometers beneath the crust. Though it is not expected to erupt any time soon, its past explosions have reshaped much of North America, scattering a fine gray ash across entire continents. It is a quiet and beautiful paradox that we have designated this place as a sanctuary, a park for quiet reflection, a place of profound peace. And yet its true nature is one of unimaginable power. Today, the region breathes gently through its geysers, releasing its pressure in spectacular, beautiful bursts that remind us of its inner, sleeping fire. Yellowstone is both a sanctuary of serene beauty and a window into the restless, untamable nature of our planet, where even beneath the most tranquil landscapes, the ancient forces of heat and pressure continue to shape the earth in silence. When ordinary volcanoes erupt, they can affect the local weather for a few seasons. But when supervolcanoes like Yellowstone erupt, they can transform the entire planet. These titanic, world-altering explosions can release thousands of cubic kilometers of ash and gas into the atmosphere, enough to block out the light of the sun and cool the entire globe for decades or even for centuries. Evidence of such eruptions appears in ancient ash layers and in climate records from ice cores, telling stories of Yellowstone, of Toba, and of Taupo. The aftermath of such an event includes a volcanic winter, a time where global temperatures drop dramatically, and ecosystems all around the world struggle to adapt to the sudden, lingering twilight. Though these events are incredibly rare, they remind us of the delicate, fragile balance that exists between the Earth's interior and its surface. When ordinary volcanoes erupt, they can affect the local weather for a few seasons. But when supervolcanoes like Yellowstone erupt, they can transform the entire planet. These titanic, world-altering explosions can release thousands of cubic kilometers of ash and gas into the atmosphere, enough to block out the light of the sun and cool the entire globe for decades or even for centuries. Evidence of such eruptions appears in ancient ash layers and in climate records from ice cores, telling stories of Yellowstone, of Toba, and of Taupo. The aftermath of such an event includes a volcanic winter, a time where global temperatures drop dramatically and ecosystems all around the world struggle to adapt to the sudden, lingering twilight. Though these events are incredibly rare, they remind us of the delicate, fragile balance that exists between the Earth's interior and its surface.
The power that is locked just a few miles beneath our feet has shaped the very course of evolution itself, sometimes triggering mass extinctions that cleared the way for new forms of life to emerge. And yet, even in their unimaginable fury, supervolcanoes are part of the planet's long, slow rhythm of renewal. They are a part of the cycle, cycling materials between the deep crust and the high atmosphere, reminding us that life and fire are and have always been deeply and profoundly entwined. And one of these events, which happened in what is now Indonesia, may have touched the story of our own species. Around 74,000 years ago, a colossal eruption at Lake Toba changed the world. It expelled more than 2,000 cubic kilometers of ash and magma, leaving behind a vast caldera 100 kilometers wide that is still visible from space today. The blast darkened the skies across the entire globe, lowering temperatures and spreading a blanket of volcanic ash over continents. Some scientists believe it caused a brief, sharp volcanic winter that may have dramatically influenced the course of our own early human populations. Even after the great eruption ended, volcanic gases lingered in the atmosphere, tinting the sunsets with brilliant colors and cooling the planet for years. The event was so vast that it dwarfs any eruption in all of recorded human history. Today, the tranquil, beautiful lake that fills the caldera seems perfectly peaceful. But beneath its calm blue waters lies one of the Earth's most powerful and dramatic scars. A quiet reminder that the planet's greatest moments of creation often come wrapped in destruction. Fine volcanic ash, the smallest, lightest dust from an eruption, can drift in the upper atmosphere for years, carried on silent winds that circle the entire planet. Particles from major eruptions, such as Mount Pinatubo in the Philippines or Krakatoa in Indonesia, have been detected long, long after the great explosions had ended. These microscopic fragments of stone, so light and so fine, scatter the sun's light, producing brilliant, fiery red sunsets, and subtly, almost imperceptibly, cooling the global temperatures for a time. High above the weather, high above our own world of clouds and rain, they form thin, invisible veils that reflect light in ways that painters once captured after those historic eruptions. The strange, beautiful skies in their famous paintings were a record of geology, a message from the other side of the world written in light. Some layers of this airborne ash have even returned to the Earth centuries later, discovered as fine, dusty layers in the patient archives of ice cores and deep ocean sediments. Every eruption, no matter how remote or how small, connects to the one single atmosphere that wraps the entire planet. The air we breathe today, right now, carries the faintest traces of eruptions from distant ages, a delicate, invisible reminder that even the calmest, clearest sky holds the quiet echoes of the Earth's fiery breath. It connects us all, a shared history written in dust, a fine powder of a mountain that once was, now a part of the air we all share. And in a few rare volcanic craters around the world, the molten rock never solidifies at all. These are the lava lakes, such as those in Ertaal in Ethiopia and Kilauea in Hawaii. They are sustained by a constant, steady supply of heat and magma from deep below.
Their surfaces churn and ripple like fiery, slow-moving oceans, crusting over in dark, brittle plates, only to break apart again as the glowing liquid rises from beneath. At night, they glow like windows into the planet's very heart, their soft orange light flickering against the dark rock and the rising smoke. The heat balance in these places is so incredibly precise, so perfectly maintained, that the lakes can persist for decades, continually and gently refreshed by a deep, slow circulation. Watching one is mesmerizing, a living furnace, breathing and pulsing in a slow, ancient rhythm. They offer scientists rare and precious insights into the chemistry and the physics of magma, things that can never be replicated in a laboratory. They are a direct view into the engine of the world. Each lake is a quiet, living reminder that the Earth's fire still burns brightly just beneath its thin, fragile, cooling crust. Timeless and powerful and profoundly alive. And from this fire, from this immense energy, comes an unexpected light. When a volcano erupts with great force, the immense friction between the billions of swirling ash particles creates powerful electrical charges. As these charges build and build within the rising cloud, they discharge as powerful bolts of lightning that crackle and flash through the dark ash plume. This volcanic lightning can illuminate the entire sky, creating surreal storms of fire and light high above the erupting mountains. Unlike ordinary thunderstorms that are born of water and ice, these flashes are born entirely from the raw energy of rock and gas. Photographs capture these moments, these beautiful, terrifying displays, showing branching bolts of pure white light arcing through towering columns of black smoke.
Each strike lasts for only a heartbeat, but it carries with it an immense and elemental power.
Scientists now study these flashes to understand the flow and the density of the ash, and to track the eruption's intensity from a safe distance, as the frequency of the lightning can signal how violently the material is being ejected. To witness one is to see the raw fusion of the Earth's elemental forces, solid rock and liquid fire and superheated gas, meeting the pure, clean energy of electricity. It is a brief and awe-inspiring display that reveals how even the most violent destruction can shimmer with a strange and an extraordinary beauty. In places where great glaciers rest silently atop active volcanoes, fire and ice collide in the most spectacular and elemental ways. When magma rises from deep within the earth to meet the ice, it melts huge volumes of water, not in hours or days, but in an instant. The result is steam, expanding with an explosive and unimaginable force. These eruptions can blast straight through the glacier, sending biblical floods and dark ash clouds cascading down the quiet valleys below. Iceland's volcanoes often behave in this way, their fiery hearts hidden beneath thick, ancient ice caps, until the pressure builds high enough to burst free in a magnificent, terrifying union of opposites. This interaction leaves behind unique and beautiful landforms, strange flat-topped mountains and steep-sided ridges sculpted by fire and water working together. Scientists call them tuyas, lonely monuments to this strange and powerful partnership of heat and cold. Each eruption that happens beneath the ice rewrites the landscape in a new and dramatic way, proving that even the most opposite elements of nature are deeply and profoundly connected in a cycle of creation and transformation, a cycle that has shaped our planet since its very earliest days. It is the Earth's own poetry, written in steam and stone. And sometimes this creative power works not to reshape the land, but to build it from nothing. All across the world's oceans, new land sometimes appears where there was once only deep, open water. Submarine volcanoes can occasionally erupt with such sustained force that they build themselves up from the dark seafloor, higher and higher, until they finally break through the surface of the waves. In the last century, eruptions near Iceland, Japan, and Tonga have created fresh, new patches of land that still steam and harden under the sun. A new island born before our very eyes. Some of these newborn lands vanish again within a few years, eroded back into the sea by the patient, relentless waves. But others grow stable enough to hold and to host life. These newborn islands reveal the planet's creative power unfolding in real time. To watch one form is to witness the very same process that built the continents long, long ago. Seeds arrive on the wind or with the birds. Plants begin to grow, and eventually life takes hold, turning the raw black lava into a new and living ecosystem. The emergence of a new island is a quiet miracle. It reminds us that the earth is not a finished work of art. It is a work in progress. The planet continues to build, to break, and to begin again, renewing its own surface, one eruption at a time. And sometimes the volcanic world creates dangers that are silent and invisible. In certain parts of Africa, a few deep, quiet lakes contain massive amounts of carbon dioxide, trapped in their cold bottom waters by the immense pressure from above. A very calm, slowly upwards from volcanic sources deep below the lake bed. Over centuries, it dissolves into the water, just like the carbonation in a bottle of soda. But when the delicate balance of temperature or pressure changes suddenly, perhaps from a landslide or a small tremor, that gas can burst upward in a deadly, invisible, silent wave. Lake Nyos in Cameroon released just such a cloud in the 1980s, a heavy blanket of invisible gas that flowed down into the nearby valleys, suffocating all life in its path. It is a rare and terrifying phenomenon, a quiet reminder of how even the most tranquil, beautiful waters can conceal an immense and silent power. And from the silent dangers below water, we turn to the silent dangers below the ground. Beneath many of our cities and fields, hidden cavities are slowly forming in the darkness, where limestone or salt is gently dissolving in the underground water. When the roof of one of these hidden voids finally collapses, the ground above can suddenly, catastrophically drop away, creating a sinkhole. Some are only a few meters wide, but others can stretch for hundreds, devouring cars, trees, and entire homes without any warning at all. Though they seem sudden, their creation is a slow, patient process. They form most often after heavy rains, when the water seeps down through the cracks and weakens the layers below. Each collapse is a quiet revelation, exposing the fragile balance between the solid ground we trust and the hidden, hollow spaces that lie just beneath our everyday world. Where limestone or dolomite dominates the bedrock, the landscape can hide a secret world of water. Rainwater, which is naturally slightly acidic, slowly, patiently carves intricate networks of tunnels and caverns through the soft stone. When the roof of one of these hidden voids finally collapses, the ground above can suddenly, catastrophically drop away, creating a sinkhole. Some are only a few meters wide, but others can stretch for hundreds, devouring cars, trees, and entire homes without any warning at all. Though they seem sudden, their creation is a slow, patient process. They form most often after heavy rains, when the water seeps down through the cracks and weakens the layers below.
Each collapse is a quiet revelation, exposing the fragile balance between the solid ground we trust and the hidden, hollow spaces that lie just beneath our everyday world. Where limestone or dolomite dominates the bedrock, the landscape can hide a secret world of water. Rainwater, which is naturally slightly acidic, slowly, patiently carves intricate networks of tunnels and caverns through the soft stone. These underground systems can stretch for hundreds and hundreds of kilometers, carrying entire secret rivers far beneath the surface. The land above often collapses in places, forming the sinkholes and the jagged ridges that are the characteristic signature of this karst terrain. Water that disappears into a quiet cave entrance on a mountainside might re-emerge miles and miles away as a clear, cold, silent spring. In some of these hidden regions, entire ecosystems have adapted to these lightless, timeless waterways. There are strange blind fish and translucent insects, life that has forgotten the sun. They are worlds that run on a different kind of energy, not the energy of light, but the subtle chemical energy that drips from the rock above. Karst landscapes are found on every continent, and they provide the fresh drinking water for millions and millions of people. Yet their hidden, secret nature makes them incredibly vulnerable. A pollutant on the surface can travel for miles through these hidden conduits, unseen, until it emerges in a spring that people have trusted for generations. Exploring them is like entering the secret circulatory system of the planet itself, a place where stone and water move together in an endless, quiet dialogue, dissolving, shaping, and renewing the surface of the earth, one single drop at a time. And inside these limestone caves, dripping water builds a silent stone forest. The water carries dissolved minerals, and as it evaporates in the still, dark air, it slowly crystallizes. From the ceiling, each single droplet leaves behind a tiny calcite ring that lengthens downward over centuries, forming a beautiful icicle-like stalactite. And where those drops land on the floor below, matching mounds of stone grow slowly, silently upward as stalagmites. In some of these hidden limestone caves, dripping water builds a silent stone forest. The water carries dissolved minerals, and as it evaporates in the still, dark air, it slowly crystallizes. From the ceiling, each single droplet leaves behind a tiny calcite ring that lengthens downward over centuries, forming a beautiful icicle-like stalactite. And where those drops land on the floor below, matching mounds of stone grow slowly, silently upward as stalagmites. A very calm, soft, and soothing voice. After an unimaginable amount of time, they can meet in the middle, creating towering, graceful columns that seem to hold the entire weight of the cave aloft.
The process is so incredibly gradual that their growth rates are measured in millimeters per century. A human lifetime is nothing to them, a fleeting breath in their slow, silent creation. Lantern light reveals their delicate, crystalline textures. They look like frozen waterfalls, sculpted not by force, but by the sheer, unending patience of time. These beautiful formations are living records of the cave's long history. They record the subtle changes in water chemistry and in the climate far above. In their layers, scientists can read the stories of ancient droughts and floods and shifts in rainfall patterns that happened long, long before any written human history. The breathtaking shapes that are found in these caves are the products of this unimaginable patience. The flowstones that drape the walls like curtains, the crystal draperies that seem to hang in the air, they all accumulate one single microscopic layer at a time, as the water leaves behind its thin, invisible film of mineral. A single centimeter of this growth can take hundreds of years. Walking through a deep cavern is like entering a slow-motion clock, a place where time itself moves at the patient, silent pace of minerals crystallizing. These subterranean sculptures are a quiet, profound reminder that the most stunning beauty can emerge not from speed or from force, but from a stillness and a persistence that is far beyond any human measure. And in the deep underground, some of these large cave networks can even develop their own private microclimates, completely distinct from the surface world. The steady temperature, the high humidity, and the gentle airflow all combine to create their own fogs, their own soft winds, and even their own tiny drifting clouds that move silently through the great chambers. Warm air rising from the deeper passages will meet the cooler air near the entrances, producing swirling, invisible currents that resemble miniature weather fronts. Some of the largest caves even experience a regular, rhythmic breathing. They seem to exhale warm air in the winter and inhale cool air in the summer. As the outside conditions change, moisture condenses on the cold stone walls, dripping down to sustain the delicate formations and the hidden, fragile ecosystems. To step inside one of these great caves is to feel the planet itself inhale. It is the rhythm of air and rock, joined together in the deep, silent dark. Beneath the rolling, gentle hills of Kentucky in the United States lies Mammoth Cave, the largest known cave system on the entire Earth. Its explored passages extend for more than 400 miles. And new undiscovered tunnels are still being found. It is a world beneath our world. The vast network was carved by ancient rivers, dissolving the deep limestone over millions of years, branching and looping into a silent, dark labyrinth that could hide entire cities within its depths. Explorers today move through its narrow crawls, its towering cathedral-like chambers, and along its underground rivers that are still to this day reshaping the rock in the absolute darkness. The air remains cool and perfectly still, and the silence is so deep, so profound, that it seems to be alive. The cave's sheer vastness challenges the imagination, a quiet, powerful reminder of how much of our planet exists unseen, just beneath our feet. And just as these caves reveal a hidden architecture within the earth, great earthquakes reveal a hidden connection that binds the entire planet together. When a massive earthquake shifts the distribution of the Earth's mass, the planet's rotation, the very length of our day, subtly changes. The effect is impossibly tiny, usually measured in mere microseconds, but it is still measurable by our most sensitive instruments. By moving enormous slabs of rock, an earthquake can slightly alter the planet's moment of inertia, just as a spinning figure skater speeds up when they pull their arms inward. After the great 2004 Sumatra earthquake, scientists calculated that the day had been shortened by just a fraction of a second. The event also nudged the precise position of the poles and adjusted the shape of the planet ever so slightly. It's a beautiful and a humbling thought that a single rupture in the crust on one side of the world can touch the very rhythm of time for everyone, everywhere. It shows us that even the most fundamental concept of our lives, the day, which feels so absolute and so constant, is influenced by the deep living movements of rock and gravity. Each great quake is not just a surface event, it is a planetary one, its echo whispering change into the very rhythm of time itself. And that echo is not just metaphorical, it is literal. When a powerful earthquake strikes, the energy it releases doesn't just stop at the epicenter. Seismic waves ripple outward through the entire planet, racing through the solid rock and the molten mantle, just like sound vibrating through a bell. Incredibly sensitive instruments can detect the same quake echoing around the world several times before it finally fades into silence. The largest quakes make the entire earth tremble, subtly flexing its crust as the energy moves from one side of the globe to the other. The planet hums, a low, resonant note that fades over hours. Scientists use these global reverberations to map the planet's deep interior, tracing how the waves bend and reflect as they pass through the molten layers. Each tremor, born of destruction on the surface, reveals something new about the hidden structure of the deep earth, where it is solid, where it is fluid, and how the ancient heat moves within. Every great quake briefly turns our world into a single vibrating instrument, humming softly with its own deep heartbeat. The sheer scale of an earthquake's energy is staggering. When the largest faults rupture, they can release as much raw power as several million tons of explosive material detonating all at once.
The shaking that we feel on the surface is only a tiny part of it. Most of the energy travels deep into the crust, moving immense layers of rock that weigh more than entire mountain ranges. It is a force that reminds us that the Earth's crust is under a constant, unimaginable pressure, always storing and releasing energy in a slow, powerful rhythm that shapes the continents and the seas over the great expanse of time. And this pressure changes the very nature of stone. Though rock feels solid and unyielding to us, deep inside the earth it behaves very differently. At great depths, where the temperatures and pressures rise beyond all imagination, rock begins to deform slowly, flowing like an extremely thick and heavy liquid. Over millions of years, this plastic, silent movement allows entire mountain ranges to rise, to fold, and to melt into new formations.
A very calm, soft, and soothing voice, slow-paced, with gentle intonation, designed for relaxation and meditation. The minerals within the rock stretch and twist, creating the beautiful flowing patterns we can now see in metamorphic rocks that have been brought to the surface. It is a quiet reminder that even what seems most rigid is capable of motion, and that the true strength of stone lies not only in its hardness, but in its ability to yield, to reshape, and to endure. And so, we come to the end of our journey tonight. The study of the Earth's long history, the story of geology, reveals that nothing, truly nothing, exists in isolation. The same immense, patient forces that lift the mountains also stir the deep seas. They recycle the ancient rocks, and they shape the delicate conditions for all of life. Fossils tell us how the slow dance of climate and geography has guided the path of evolution, while the quiet crystals within the rocks record the deep, fiery processes that have sculpted the continents we call home. Every river carries the memory of erosion, and every single grain of sand on every beach once belonged to a great and silent stone. Over billions of years, the great cycles of plate movement, of volcanism, and of weathering have woven together a single unbroken story. A story that connects all land, all life, and all of time. Geology is the language of that story, the quiet, beautiful script written in the endless layers just beneath our feet. Every pebble, every cliff face, and every mountain is a page in the vast, quiet diary of the earth. Within their grains lie the clear records of ancient seas, of fiery world-building eruptions, of silent, grinding glacial ages, and of the slow, majestic drift of the continents. Rocks remember the crushing pressure and the purifying heat, the great floods and the long droughts, They remember creation, and they remember decay. Together they form the grand, silent archive of time itself, standing upon what feels like solid ground, feels like permanence. But in truth, we are standing atop history in motion, a thin, fragile crust that is forever forming, breaking, and then gracefully reforming. To listen to the earth is to hear its long, quiet memory, the soft, deep murmuring of stone, recording the story of a world that has never, ever stopped changing, growing, and remembering itself. Even now, as you rest, the ground turns slowly under the stars, stars that once forged the very minerals that are now in your bones. Beneath the quiet crust, molten rock flows in endless, graceful cycles, shaping continents that drift like slow, silent clouds across a hidden sea of stone. Geology reminds us that the greatest changes do not always roar. Most of them just whisper. Mountains rise grain by patient grain. Oceans open wider than any memory can ever hold. Every pebble, every crystal, every grain of sand carries the quiet trace of a time so vast that our own stories seem like the briefest flashes of light in a long, dark hall. Yet those flashes, our lives, are part of the very same pattern, written into the same ancient fabric of the planet itself. Somewhere deep within the earth, pressure is building, and somewhere else it is easing, and a new rock is beginning its long, slow transformation. Far, far above, the wind is grinding stone to dust, and that dust is drifting across oceans to feed new life. Everything that ever was becomes something new again. The planet breathes in the slow, deep rhythm of stone, and we breathe with it, without ever even knowing. You might think of the places you have walked, the quiet sound of gravel beneath your feet, the rough, cool texture of a cliff face, the soft warmth of sand between your fingers. Each is a story being told to you in the language of minerals, shaped by time and shaped by your own touch. The world is not just alive on its surface. It lives deep within itself, turning memory into matter, turning a deep, profound silence into a beautiful, solid form. As you drift now toward sleep, let that thought sink gently, like soft rain through soil. Imagine the deep, steady pulse of the planet far, far beneath you, ancient and calm. Let it quiet your own thoughts and slow your breathing. You are a part of this story too, a brief, beautiful, shining moment in a vast, unfolding world that remembers absolutely everything. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, just breathe. Let your eyes grow heavy, and let the planet cradle your thoughts. Still, patient, and eternal. Sleep well, and good night.